Here we go. Today's exercise, we're going to move to exercise, quiet down. We're going to move to exercise 5H, but before I do, I'm going back to 5E and just talking about change of bases. It's on a theoretical point, like if it's in the exam, you don't really need to use it except for a multiple choice question. There was one for question 22. It was the last question of multiple choice, and in order to do that, you had to understand what change of bases was. Nowadays, you don't feel the need to do it. Back in my days, you would. And the reason why is because your CAS now can do any base. So, for example, if I asked you to type in your calculator log base 2 of 7, your calculators can do that. Whereas my calculators in the time when I did it, I can't do that because we can't do it with a log base 2. All calculators at the time could only do log base 10 and log base E, which is called the log natural number. Okay, that's why it's ln. Those are the only two that we were able to do. We cannot do with the base 2. So that's why this technique at the time was something that we had to learn. It was part of my exercises. But for you guys, you just need to find the theory and sort of understand the theory, and that's about it. Everything that I teach is all about inverse, is all about the fundamentals. You get the fundamentals, you can easily prove this and then show that this is the rule. But anyways, this is what the rule is saying. Whatever the base is, so log base 2 of 7, that is equivalent to log, now B could be any base you want. It could be log E, or it could be log 10, or whatever it is. But according to this formula, I could type in my calculator log base E of 7, because X is the 7, divided by log base E of the current base, which is 2. See, on my calculator, I can do that. I can type in log base E of 7, I can do log base E of 2. I can do that on my calculator at the time. The question is, where is that formula coming from? Most students would just memorize that, and I don't want you to memorize it. I want you to think about it. Yeah? So here we go. I'm going to show you the understanding and the skills that you currently already have and how to show that that is true. Okay? Because I don't actually remember this rule. I just work it out when I need to. Okay? So here we go. Let's say I don't know how to find log 2 of 7. Okay? I don't know how to do that on my CAS. All I know is log 2 of 7 has to equal to something. It has to be equivalent to a number that I don't know. In that case, I'm going to call that X, because I don't know what it's equal to. But it's a number, right? So if I stick to that, right now we don't know logs, but we do know exponentials better. So what I'm going to do is I'm going to get rid of the log base 2 just to change this to an exponential. Now, what have I taught you so that you can remove the log base 2? What's the inverse of log base 2? Exponential with the base 2. So what I'm going to do is I'm going to say, all right, balance the equation on both sides. I'm going to do 2 to the power of and 2 to the power of both sides. In this case here, I'll be doing on the right-hand side 2 to the power of x. And on the left-hand side, it'll be 2 to the power of log base 2 of 7. That's what I'm doing to balance the equation on both sides, yeah? So by doing that, we know that 2 to the power of log 2 are inverses of one another. They cancel out, and so you're left with 7 is equal to 2 to the power of x. Okay? Now why did I do this? Is because I've gotten rid of the log 2, because that's something I don't know. My calculator doesn't know what a log base 2 of 7 is. But now what I can do is I can change this side now to log whatever I want. In my case, I want to log either E or log base 10. So let's say I say log base 10 of 7 on both sides now. I say, all right, I can do this on my calculator. I can't do log base 2, but I can do log base 10 of 7 on the left. So I'll just do it over here. I'll do log base 10 of the left-hand side and log base 10 of the right-hand side. In my case here, it would be 2 to the power of x, and this one would be 7. True? Now this I can do on my calculator. That one I know. Log base 10 of 7, I can do that. Okay, I couldn't do log base 2 of 7 before, but I can do log base 10 of 7. That's what I can do on my calculator. I can also do log base 10 of 2. The problem is the x. That's what I do with the x. There's only one rule I kept teaching. Naz? Yeah, that's rule number 3. And that's the one most students forget. Or the ones that in the exams they tend to sort of forget. This helps you to solve this problem. I can bring the x down by rule number 3, and if I bring the x down, I now have x multiplied to log 10 of 2 is equivalent to log 10 of 7. Now you can see from here, my goal is to find x. Why did I want to find x? Because remember, x was 1 log 2 of 7x. If I can find x, I've got my answer. Yeah? So from here, I want to find x by itself. I got to get rid of times log base 10 of 2. So the opposite of timesing log base 10 of 2 is dividing. Opposite of times is divide. Yeah, so in this case here, I'm going to divide both sides by log 10 of 2, and this is how I get it. I get log 10 of 7 divided by log 10 of 2, and this side, if I divide by log 10 of 2, they cancel out. They divide out to be 1. So now I've got x. That's why this x here, which I can replace up here, it makes sense why x is equal to log 10 of 7 over log 10 of 2. Okay, so you see what I'm doing there? So I know that's just the proof for it, but what I'm just showing to you, can you see why it doesn't matter what base it is? It could be log base e of 7 divided by log base e of 2. It can be log base 10 of 7 divided by log base 10 of 2. And the only reason why is because this is the step. That's the step. I got rid of the log 2 because I couldn't do log 2. Here, I chose whatever log I want. Log base 10 on both sides, or log base e, or log base whatever you want on this side. Okay? And that's the theory there as to where that formula comes from. Okay, so you don't need to memorize it. All I did throughout all this, I haven't done anything different. Inverse of times, divide. Inverse of log, exponential. Inverse of exponential, log. That's all I did. I haven't done anything that's new. It's all in chapter 5 algebra. Okay? So that's how the formula comes about. And that will be useful for one. I'll try to find that question again. I remember it's 22, but I can't remember which year. It might have been a 2013 or 2014 multiple choice exam question. The only way to do it is to understand change of basis. Because they use A and B's and C's, there was no values for you guys to use on your calculator. That's why. Okay? But that's one part. That's change of, these are called change of basis. So if you're interested, they're called change of basis. That's the name for this skill. Okay, and like I said, back in my time, that's what I had to do in order to find out log 2 of 7. Your time, you don't really need that. You can just type in your calculator and you'll be fine. Yeah, that's why exercise 5, if you went through it, you'll find that you didn't have to learn the skill. I'm just showing to you in case it comes up in an exam. Okay, now another one in exercise 5E that I thought was cool, which relates to what you've been learning, chapter 3, transformations. This is the question. I'm going to do question 6 with you. I'm going to get you to think about it, and I'm going to get you to do 7 after. Yeah? So here we go. Let's look at 6. It says you got y equals 3 to the power of x. What transformation will I have to do to change this equation to e to the power of x? So what I'm saying is, normally you got an xy coordinate. What would you have to dilate or reflect or translate in your transformation so that you can get this equation? The problem to this, why a lot of students find this difficult, is because the bases are different. In exponentials, you don't know how to change a base, right? What will we have to do? And the first thing you have to realize is the goal. What is my goal first? Then we're going to work backwards to try to figure out the answer. Because I can give you the answer and you can memorize it, but at some point you're going to forget it. So it's better for you to make a goal, establish a goal, and then try to work towards it. Because it's kind of like a puzzle. The puzzle is, what is my goal and how do I get there? Yeah? So first question is, what is the first goal? I've got 3 to the x, and I want to get to e to the x. What is the first goal? What am I trying to achieve in my transformation?
We want to change the equations so that they become to a point, they get to a point where we can easily recognize the difference between the two.
Yes, but something more specific. You're right, that is what we want to do, but I want something specific. You just want to change the base. So what you're really trying to say is you want to get rid of 3. Yeah, you don't want the 3. That's really what you're saying. You want to say, I want to get rid of the 3. But how do you get rid of a 3? You've got an exponential base 3. What skills have you learned now? See, I've got a goal for you. The goal is to get rid of a 3. What have you learned so far that can get rid of a 3? Log base 3. So this is now the thing that we've got. Okay, we're like, all right, I need a log base 3 somewhere in my transformation, either to the x or to the y, to get rid of the 3. That's all I want. I just want to get rid of the 3. Now you're right, it is a log base 3. The question is, when you're doing transformations, there's only dilation. So you either multiply x by something, or you multiply y by something, or you add x by something, or you add y by something. Those are the only things you've got. So how is it possible? This is where the problem solving comes in. Because once I give you the answer, you're like, oh yeah, that makes sense. I want you to think about it. What kind of transformation, what would likely work? Or even easier, let's eliminate what definitely won't work. So you said log 3. What definitely wouldn't work for a transformation that wouldn't work? The transformation, what wouldn't work? Plus or minus. That's the most logical one. Because if I just did, if I said add, because we said log base 3, if I said x plus log base 3 of, I don't know, let's say e, that doesn't work, because that means now I'm going to say plus log base 3, oh sorry, it's minus, becomes minus, ends up being minus, log base 3 of e. That doesn't help me cancel out the 3. How do you cancel out a 3? See, what would I have to do? We clearly can see that adding or minusing it won't help. Even if I added log base 3 of e, it doesn't cancel out. That doesn't help to cancel it out. So, we already know adding, subtracting doesn't work, so translation is not going to work. We now know it's either reflection or dilation. Okay, so we know addition doesn't work. We can remove all that. We can say, all right, it has to be something times either y or something times the x. Okay? Now we've got dilation and reflection, and reflection is just a negative. Okay? Now we know that it was log base 3. Okay, so let's try that. Which one would I times? So this is my x and this is my y. Would I times the y by 1 over log base 3? Or would I times the x by 1 over log base 3? Y. So if I times y by 1 over log base 3, so let's have a look. This is what, when you're doing a dilation with a y, it's a dilation from the x-axis, true? So it would be y equals to log base 3, 1 over log base 3 of something, times 3 to the power of x. Now can we cancel out those 3's? Is that possible to cancel out? Can I just go cross this out, cross that out? It's a yes or no question. So I'm asking, can we cancel that out? Yes. No, we can't. We can only cancel, remember the only way we've been cancelling before, which I'll show you again. See, the only way I cancelled it before were inverses. So look at this, I did 2 to the power of log base 2. Or I did, or in this case, if that was a 10, log base 10 of base 10. But I never did log base 10 of something times 10. That never cancels it out. So, we are close. Just one more little bit. Yes, Leah?
The example you did before, we had 2 to the power of log base 2, 7 equals 2x, and we cancelled it to 7. Should we do something similar to this?
Absolutely. And that's what I'm trying to get at. What you're saying is absolutely correct. So, the one that we just did before, which was this step here, where we had 2 to the power of log base 2 of 7, these two cancel out. True? That was the only way I cancelled out the base. So when you say, I want to get rid of 3, you're trying to aim for this. The problem is you have the x. Let's think about it. You know, this is what you know. I'm going to formulate what you want. This is what you want. Instead of 3 to the power of x, what I know what I want is, this is what I want. I want 3 to the power of log base 3 of something. I still have the x there. See, the 3's here will cancel out. You're right. That's the step I did before. And that's what you all used to. So at this point, I know that these 3 will cancel out. It's true. But how do I get that log 3 there? What am I actually doing? Yeah, very good. It's not a dilation dealing with my y values. You see, before when I was saying, am I dilating it with the y or am I dilating with the x? It's not the y. This is a dilation relating to the x values. Now, just to make it easier for you to think about, if I gave you this one, if I asked you what kind of transformation this is, what would you tell me? 1 over 2. From which axes? from the y-axis. So you would say the transformation is like this. xy becomes half times xy. True? Now, instead of 2, why can't I have log base 3? Now, I still don't know what it is of x. See, all I'm doing is instead of log base 3 of 2, that's 2 times x. True? All I'm doing now is just say, well, why don't I do log base 3 of, I don't know, let's do 8 times x. So what would the transformation be for this case here? 1 over, yeah, log 3 of 8 times x is my transformation. Does this make sense what I'm doing? So I'm just doing a comparison. If it was 2 times x, you told me is 1 over 2. Then if I have log base 3 of 8, then you would tell me it's 1 over log base 3 of 8. True? And the nice thing is this will cancel out. Log 3 of log 3 will cancel out. But what's the problem? Still have an x there. Remember, you can't just cancel out if you have a times or a coefficient at the front. So what do you have to do? What do you have to do? So I'm trying to get you to think about the skills that you have so far. There's only one rule. There's only one thing you have to do before you can cancel it out. You can't just cancel these out and say the x is 8x. It's not true. It's not 8x. How do you cancel things out? Fantastic. The only way to cancel them out is you have to use log rule number 3. This would be 3 to the power of log 3 of 8 to the power of x. You see that? You can say, cancel this out. But then that means I've got an answer of 8 to the power of x, but I didn't want 8 to the power of x. What did I want? So what would the base have to be inside then? E. So if I just change all that to an e, this will be e to the x. They'll change to e to the x. So that means my transformation that I actually really want is xy. The only way to change 3 to the x to become e to the x, it has to be a transformation of 1 over log 3 of e times x y. Okay? Now just to do it, no. It's just to get you thinking again. I'm going to do it again. Here we go. Let's do something that you know, yeah? So let's do something that we know. When I said 3 to the power of x, and I want to change it to y equals to 3 to the power of 7x, and I asked you for transformations, what would you tell me? 1 over 7, that's a factor. What you would say is the transformation is xy becomes 1 over 7 times x. True?
Yes.
Okay, so that was 7 times x. Now what I'm saying is, well, why is it different? If I have y equals 3 to the x, why don't I say, instead of a number, so you're used to seeing a number, why does it have to be a number? Log 3 of 7 is a number, it's just written differently. I can have 3 to the power of, instead of 7 times x, why can't I have log 3 of 7 times x? What kind of transformation would this be then? This would be xy, and it'd be 1 over log 3 of 7. Exactly the same thing as you just told me. You just said, for number, you had no issues. It was 7 times x. You're like 1 over 7. Over here, I say, well, log 3 of 7 times x. That'll be 1 over log 3 of 7. Same thing. They're just numbers. 7's a number. Log 3 of 7's a number. Yeah? So this number is the dilation factor. It's 1 over log 3 of 7, whatever that is. The nice thing about this is I know the log 3's have a potential to cancel out. But you can't cancel it out unless you bring the x up. That's what we've always been doing. We can't cancel out if you have an x at the front or a number at the front. And so what we know, in our case before, what we wanted was, we wanted this to be xy 1 over log 3 of e times xy. This now will change y equals 3 to the x, becomes y equals 3 to the log 3 of e times x. Now if you simplify this equation, y equals 3 to the power of log 3 e to the x, we can now say, sorry? Rule number 3. Bring that up.
Why is there another x on the transformation?
This one. Well, let's go back then. Why is there another x in the transformation?
Oh, wait.
It's the same thing. You said 1 over 7 times x times x times x. All right, there you go. That's your change of basis. Now, what I want you to have a go is number 7. So I did number 6 for you. Same thinking. Same thinking. E to the x, I want you to change that base to 2. So you make a goal and then start working backwards to get there. Okay, so I gave you a sort of approach. You always have to establish a goal. Otherwise, you're just running around in circles. Okay? You want to establish a goal and use tools to figure it out. That's what maths is. Yeah, it's all about using tools and what you have. So I'm going to change this now. We want e to the x. Want to change it to 2 to the x. So what would the transformation be? X, y. I want to know what the transformation is. Okay? Who's got an answer? Transformation of what? What would our answer be? Yes, Phoebe.
Dilation of factor 1 on log e to 2.
Fantastic. Okay, it's dilation of factor 1 on e, because remember, if this is your dilation factor, it will now be y equals e to the log e of 2 times x. Simplify that equation. That becomes e to the log e of 2 to the power of x. And then these log cancels out and you get 2 to the power of x. But what you have to remember is log e2, if that was a 2, you would have told me a dilation factor of 1 over 2. If it was a 7, you would have told me it's a dilation factor of 1 over 7. So if it's log e of 2, then the dilation factor has to be 1 over log e of 2. Okay? And so it's a dilation of factor. So if you were to answer the question, it's dilation of factor 1 over log e of 2 from the y-axis, because you're dealing with your x values. Okay? There you go. So I'm going to put red here. There you go. That's my answer. But that's the logic. Okay, so 6 and 7 was just a nice question to apply what you've learnt in Chapter 5 algebra and then what you've learnt in Chapter 3 transformations. It's a nice question. Okay, so it's just a little trick. I know I can just tell you at the start, just do the 1 over this, but that's not helping you think. I want you to start thinking. Make a goal and then try to approach that. Okay, because in your SACs and your exams, that's how it's going to be. You're going to have to make a goal to get there, because all of you will have the skills to do the questions. None of those questions at the end of your exam should be something you don't know. It's everything that you do know. The question is, what's the goal? That's why extended responses are hard, because most of the time you don't know what the goal is. You read the question and you're like, what is it asking me? Maximum, minimum, what is it asking? Length, time. That's why it gets hard, because you have to establish a goal and then work backwards to try to get to where you want. Okay? And that's hard to teach, because how do I teach you to work backwards? I can teach you a method, but at some point you're not going to have me around to tell you what to do. You have to think about it yourself. Yeah? All right. Well, that's pretty much just all from 3E there. Exercise 3H.
3.
Oh, sorry, 4. 5? 5. 5E, and this is 5H here. Yeah, we're in Chapter 5, exponentials and logs. Exercise 5H is really just about inverses. Most of the time you've already learned all the skills you need. Now for all the inverse questions that you're doing at the end of your exam, there's always a few things that you've got to do. Find the domain, find the range of the inverses, find the inverse equation, and sketch both of them on the same axes. That's the same questions that keep coming up over and over. And the ones that most students hate, sketch on the same axes, find the range of the inverse.
They find the range.
Sorry, find the domain of the inverse. The domain of the inverse. Those are the two that are generally hard. Finding the inverse, most students will know, swap the x and y's. Well, if you don't have a CAS. Yeah. Okay, so in this case here, all I'm trying to get you to do is think about this question here. You want to find, again, I'll say domain of the inverse, range of the inverse. You want to know what the inverse equation is. Okay, and then you want to be able to sketch it. Those are your two goals. Now, what I'm saying is when you're doing these kind of questions, you should already get 1 mark from getting domain and range of the inverse. Because they always give something to you already. What have they given to you? The domain. What's the domain of the, domain of the function, which is the range of the inverse. And in this case here, they already told me the domain is R. So you should already get, everyone in this room should be able to say range of inverse is R. Okay, now you don't get a mark for that. You have to get the domain to get 1 mark. Okay? So, in order to do that, you need to find the range. And this is why I always say methods. The better you can visualize the graphs, the easier it is to do methods. So if you have a look at this graph here, you've got e to the negative x plus 3. What transformations do I already have? What's a negative do to the graph? Reflection in your y-axis. So an exponential graph reflecting the y will now look like this. What's the plus 3 do? Elevates it up by 3. So it only changes what? Not the y-intercept, or y-intercept and the asymptote. So now I know the asymptote has gone up by y equals 3, and I know the shape looks like this. So if it looks like that, you can now tell me what the range of the function is. What's the range of the function? 3, not including 3, all the way to infinity. So that means the domain of their function, or inverse function, should be 3 to infinity. That's why I'm saying 1 mark is easy to get for these inverse functions. It's always the same. The better you visualize. It's the problem when you can't visualize it, then it's hard. The problem when you can't read the transformation, that's when it's hard. That's why chapter 3 was big for your SAC. Yeah? It's all about reading and visualizing what's happening.
What about when there's 2 inverse functions?
2 inverse functions?
Like a plus minus a square. Yeah.
Plus minus.
Like on the SAC?
Oh.
I got it.
Yeah, I didn't.
We'll go through the SAC eventually, but if you had a plus minus, you have to look at the domain and range to see, because it won't be a function.
Yeah, so it was like, one of the questions was like weird.
Ah.
What?
I think you would have to look at the domain and range. Yeah. Don't. Like I said, just keep calm, move on, yeah? All right. Now, to find the inverse function.
The main of that question was x is greater than 0 or something. So using that find out that like one of them is cancelled out, which is probably the negative.
And that's what I was going to say. There's always a hidden domain. And I always told you, domains of any function, highlight it, underline it, because they matter. And that's exactly where it is.
So the range of the next one. So anything range.
Good. Now, to find the inverse function, here we go. We're going to swap the x and y's. X equals to e to the negative y plus 3. I want to find out y to find the inverse function. What do I do first? Yes, Luke?
You push the minus sides by 3.
Good. So it becomes x minus 3.
Then you log base e both sides. So
Good.
Wait.
Well, no?
Wouldn't that be log base e x minus log base e 3?
Because that's all the left-hand side. So when you say log, you log the entire left-hand side. So this would be log base e of the entire left-hand side, log base e of the entire of right-hand side. Okay? Now, I'm just going to move this one down. So from here, we can now see that this is log e of e. We can cancel that out and the answer will be negative y. Yeah? Remember, you can't just cancel these out if you have that times there. So here we go, log e of e will cancel out. We can say this is now negative y is equal to log e of x minus 3. Divide both sides by a negative. Y equals negative log e of x minus 3. Now, Am I done? No. Every time you get define a function, find a relation, find the inverse, or define the rule, whatever that is, I always ask you to do what? What do you have to do? Domain and write in function notation. Okay, so in this case here, you do not use y. It's not y, because I never gave you y. Y was a made-up variable just that makes it easy. You were given f of x. So your answer should be f inverse. Write the domain, so function notation. Our domain was 3 to infinity. Maps onto R. F inverse of x is equal to negative log e of x minus 3. That's how you write your answer. Okay? So you can see there, see the working out that I'm doing. This is your proper answer for 2 marks. You get a domain, you get the inverse. 2 marks there. Then you get a separate question where they'll say sketch f of x and sketch the inverse. Now I already sketched f of x. That's f of x. Let's sketch now the inverse. That's always been the tricky one. Now if you got the equation, hopefully you can visualize from this equation. You can read that equation, draw your log graph, or you can try to reflect and do a symmetry along y equals x. Yeah? But if I were to do this, let's have a look. Y equals x. If you did a reflection or the inverse, instead of y equals 3 being your asymptote, your new asymptote would be x equals 3. So here we go. It's a vertical asymptote at x equals 3, which makes sense, because if you read that, it tells me I'm moving to the right by 3. It also tells me there's a negative, so it's a reflection in your x-axis, it's upside down. So if you were to sketch this, it should look like that. And it makes sense because if you tilt your head, it should be symmetrical. It should be symmetrical along this line. It's meant to be very symmetrical there. And that's my logarithmic graph there. Okay, so you got your f inverse. But if they're asking you to sketch, you must label the intercepts. Now it's probably easier to find out the y-intercept rather than trying to find the x-intercept. Y-intercept of the original function. What's the y-intercept here? 4. Let x equal to 0. E to the 0 is 1. 1 plus 3 is 4. So if it's 0, 4, it's 4, 0. There you go. Perfect graph. Okay, so you got your shapes, label your axes, label your functions. But that all there is the skills that you need. Like put in transformations, algebra of your logarithmic equations, properties of inverses, chapter 1 and chapter 5 algebra. Okay? That's exercise 5H for you there.
5H.
That's 5H. Okay? 5H. But I'll give you some time. That's your time to catch up, whether you're up to E or not. Chapter 5 is all about algebra. The better your algebra is for chapter 5, the easier it is for all of it. It's all about your algebra. Work on your algebra.